Hello, Math 20-1 students. We're looking at lesson 6.1, rational expressions. So what I wanted to do was show you a rational number. So that's what you have seen in the past. So 4 out of 7, or 1/2, or 3 out of 5, those are rational numbers, versus a rational expression is when you have a variable on the top and at the bottom. Okay, so you're actually dividing a variable in the top and bottom, versus here it's just a fraction. So that's kind of the main difference between a rational number and a rational expression. So our greatest common factor, you need to be able to factor that out. For example, 5x plus 10, you need to always take out the greatest common factor, which in this case is 5. You would take that out by dividing both values by 5, leaving you with 1x plus 2. Okay, so that still means the same thing, but it's factored. So that's what we want to practice in this lesson especially. Difference of squares. Let's say you had x squared minus 25. We would have to factor that as x minus 5 and x plus 5, where we square root the first number and the second number to split it up. So factoring is going to be very important for this unit. So this is our rational unit, and it's very important for math 30-2 and 30-1. So in 30-1, you will see a lot of these concepts repeat, and 30-2, it will be the exact repeat. So you'll see this unit all over again if you decide to go into math 30-2. Factoring trinomials. So whenever we have x squared plus, let's say, 2x plus 1, we want to factor it and say that we want to find two numbers that multiply to this number and add up to this. So it has to multiply to this, add to this. So x plus 1 and x plus 1 would add to 2 and multiply to 1. So those would be the factors. So our first concept that you need to remember are non-permissible values. This will come up a lot in math 30-1. So non-permissible values come from the bottom fraction, the denominator. So this is called your denominator. What you want to do is you want to take your denominator, you want to make it equal to 0, and then you want to factor it if it's possible, and then solve for x. In this case, you'd move the minus 3 over to give you positive 3, and that is a non-permissible value. That is the value that will make the bottom 0, and that is actually not allowed. You are not allowed to have x equal to 3, because if it is, the whole question doesn't exist. So we want to find out the non-permissible values that will make the variables, the bottom especially, equal to 0. So we don't want the denominator equaling 0. That's a big no-no. Well, whenever you have just multiplication, no addition or subtraction, b is not allowed to be 0 and c is not allowed to be 0. Because if b is 0, the whole thing becomes 0. Or if c is 0, the whole thing becomes 0. The next one, what you want to do is take each factor, meaning x plus 2, make it equal to 0. And then you want to take the other factor, x minus 3, make it equal to 0. Solve for them, because those would be the values that would make the bottom 0. So if I bring positive 2 over, I get negative 2. So x is not allowed to be negative 2. And then if I bring minus 3 over, I get positive 3. So x is not allowed to be positive 3. So those are your two non-permissible values, and these are your two non-permissible values. So only variables will give you those non-permissible values. Here you want to factor first. This is a difference of squares. So we want to take y minus 2 and y plus 2. That's the factored form of y squared minus 4. You want to take then y minus 2 with the first factor, make it equal to 0, and y plus 2, make it equal to 0. This is like solving for the x-intercepts in our previous unit. So it's the same concept that we're using, but we're just looking at the denominator only for non-permissible values. So y cannot equal positive 2. And y cannot equal negative 2 from this one. So those are our two non-permissible values. Our next idea is creating equivalent rational expressions. So to create an equivalent rational expression, As long as you multiply the top and the bottom by the exact same thing, they are going to be equivalent. For example, 7s squared over s squared minus 2s. What I did was I multiplied everything by s, and now it is equivalent. So that's one option. I could multiply by a number. I multiplied everything by 2, the top and the bottom. As long as you multiply to every term, it's still the same. I could multiply by another variable. So I multiplied the top and the bottom all by x. So those are all equivalent examples. Simplifying rational expressions. So to simplify, back when we were looking at fractions, what we did was you would divide the top and bottom by the exact same number. Well, I'm going to show you another technique here that also works, right? So what we want to do is we want to break up the number as much as we can. So we want to break up 12 and 36, so I can break it up as 12, and the bottom I can break up as 12 times 3, because 12 times 3 is still 36. The reason I do that is now these are factors, and when I see factors that are identical in the top and at the bottom, I can cross them off, leaving me with the answer of 1 at the top. Since I crossed everything off, you still need to write a 1. And 3 at the bottom, since that's the only thing left. So that is simplifying. I'm going to do the same thing here. So x to the power of 3 and y, and x to the power of 3 and x to the power of 4, these guys still add up to 7. So you still want to make sure you have the exact same numbers left over. And then the y I'm going to write as y1 and y2. As you can see, the 3 and the 4 at the bottom of x's still add to 7, and the 1 and the 2 still add to 3. The reason I do that is because these guys can cross off because they're identical, and the y1 and the y1 at the bottom and top can cross each other off, leaving me with 1 at the top and x4 and y2 at the bottom. So that would be my final simplified answer. Example number 2, we want to factor everything first, and then we want to see are they equivalent. So this is going to be first substitution. I can substitute, I don't recommend you use 0 or 1. I'm going to use 2 to substitute. So 2 is usually a safe one to substitute, or -2 or +3 or -3. So I'm going to substitute 2 as x. So for the first expression, 2 times 2 plus 2, and then 2 squared plus 3 times 2 plus 2. I'm going to do that for the other expression, 2 over 2 plus 2, so that's going to be 2 over 4, which simplifies to 1 over 2. This one's going to be 4 plus 2 is 6, and then 2 squared is 4, 4 plus 6 is 10, plus 2 is 12, and then 6 over 12 can simplify as 1 over 2. As you guys can see, 1/2 equals 1/2. So they are equivalent, so that means that they are equal to each other, therefore equivalent. So as long as if you substitute, they give you the exact same answers, then you will find that they are equivalent. Another way of proving that they are equivalent is by factoring out the common values. So for 2x plus 2, I'm going to take out the common 2 at the top. So I'm going to factor the top. And I'm going to factor the bottom as 2 brackets. 2 numbers that multiply to 2 and add up to 3 would be x plus 2 and x plus 1. So the reason I did that is because now I have the same factors at the top and at the bottom. These guys can cross each other off, leaving me with 2 at the top and x plus 2 at the bottom. And we can see that it is equal to this one. So they are equal. Therefore, equivalent. Once you simplify, they should always look the same. Example number 3, we're going to factor the top, factor the bottom, and then cross off factors that are the same. And we also want to find the non-permissible value. So I'll show you when's the best time to do that. So for the top, you're going to have to factor it properly. So we're going to have to multiply the first and last terms together. So that will be two numbers that multiply to negative 20. And they have to add up to the middle, which is positive 1. So I know that my answers are positive 5 and negative 4. So positive 5, negative 4, and if you're doing the fraction method or box method, it doesn't matter, but you do need to write it out. So 2y and 2y squared, I'm going to write that out, divided by 5 and negative 4. Those are my two numbers I just found. So this is the fraction method for working with factors. So I can see that 2 and 5 can't simplify, but the y's can cross off. One y from the top, one y from the bottom can cross off. And so I'll have 2y plus 5 as one bracket. The other bracket I can simplify as dividing by 2, y over negative 2. The bottom, you just need to find two numbers that multiply to negative 10 and add up to positive 3. So that would give me y plus 5 and y minus 2. Okay, so those are the numbers that would work. So again, the reason I do this is because I can see that these two guys can cross off each other. But before I cross things off, this is the best time to find non-permissible values. Those are called NPVs. So you always want to look at the bottom, and before you cross things off, you want to say, well, y plus 5 could equal 0, and y minus 2 could equal 0. If those are equal to 0, the expression doesn't exist. So what values will do that? Well, y cannot equal negative 5, and y cannot equal positive 2 by bringing those values over to the other side. So those are our non-permissible values. Once we find our non-permissible values, then it is safe to cross off those factors that are the same at the top and bottom, leaving us with our final answer of 2y plus 5 over y plus 5. This is our final answer. So you cannot cross off the y plus 5s because they are attached to each other. So whenever you see addition or subtraction, that is like glue. You can't separate those items apart, so you can't touch them. So just because you see a 5 doesn't mean you can cross it off. You have to have only multiplication between them to cross items off. So that's why this is our final answer. Stop here. For B, same idea. We want to start by factoring out the common value. So I'm going to take out a 2 from the top, leaving me with 3 minus m. And then the bottom is a difference of squares. So I'm going to write out two brackets and write it as m minus 3, m plus 3. Now what I like to do is over here you'll notice that you have similar numbers but the wrong sign. So I'm going to swap the order of them. I'm going to write minus m plus 3 at the top just so I can see that they look the same but they're not actually equal to each other. So they look the same, they look similar but not the same really. What you can do in this situation is you can take out a negative value from the top. You can factor, instead of factoring out a 2, I should have factored out a negative 2. If I do that, that changes your signs. Negative m will become positive m, and positive 3 will become negative 3. So the signs will switch within the bracket of your choice. And now I can see that there are factors that are identical. Factors have multiplication between them, not addition or subtraction. Before I go on, this is where I'm going to find my non-permissible values. Only look at your denominators. I have m minus 3 and could equal 0, and m plus 3, if it's equal to 0, don't exist. So that means m cannot equal positive 3, that's one solution, and m cannot equal negative 3. Those are our two non-permissible values. Now I go back and I cross off these are the same and these are the same factors. leaving me with a final simplified answer of -2 at the top over m plus 3 at the bottom. So that's my final answer with the non-permissible values of 3 and -3. So don't forget, reducing rational expressions involves canceling factors, not terms. So don't cross off stuff that looks the same if they have addition between them. Only cross them off if they have multiplication between them. And now over here we're going to factor. So that's what we're trying to practice. So factoring would look like this. This is a difference of squares at the top, leaving you with 4x minus 3y and 4x plus 3y. At the bottom, I can take out the common value of 2, leaving me with 4x minus 3y. So the reason I do that is because these guys can cross each other off. This crosses itself off with that factor, which is much easier now to work with because now you have 4x plus 3y over 2. That's our simplified expression. What we want to find is what is the non-permissible value for y if x equals 3? Well, the non-permissible values always come from before we cross things off. So we have to look over here at 4x minus 3y. We have to make that equal to 0 because that was before crossing things off. Find your non-permissible values. So we're going to make x equal to 3. So that gives us 12 minus 3y equals 0. Now we want to solve for y. 12 equals, we're going to bring that negative 3y to the other side. It'll be 0 plus 3y. 0 plus 3y is just 3y. And then divide both sides by 3. Y cannot equal 4. That's our non-permissible value for A. Now they're saying evaluate our final expression from here with x being 1.5 and y being 2.8. So 4, and then times 1.5 plus 3 times 2.8. Divide that whole answer by 2. So in my calculator, I'm going to go 4 times 1.5 plus 3 times 2.8 and divide that answer by 2. You should get that the answer is 7.2. So why is it beneficial to simplify? Well, there's way less work for substitution. Way easier to substitute.